So we'll look now at turning points within cubic graphs. So obviously within quadratic graphs we had either a maximum or a minimum. But within our cubic graphs then we could have both. We'll have a maximum then a minimum, or the minimum then a maximum. So it just makes things a wee bit more complicated now for these questions. So again, same thing for each question. Find the turning points. Now this time plural, the turning points. The following curves. And state their nature. Okay, so first one then. Y equals 4x cubed plus 2x squared minus 6x plus 4. Now we go about this in exactly the same way as we did with the quadratic. So the first thing we do is we say, right, find dy by dx. So we get 12x squared plus 4x minus 6. And then we say, for turning points, dy by dx equals 0. So we have 12x squared plus 4x minus 6 equals 0. So this is where these questions will be slightly more complicated because we have a quadratic to solve now. Okay, for this question here we have to use the quadratic formula to solve it. So x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we get our two answers, 0.560 and minus 0.893. And that's both the 3 decimal places. Now we need to find the y coordinates, and then we need to find which one's minimum, which one's maximum. Okay? So first thing I'm going to do is find my second differential. So d2y by dx squared, by differentiating this again, so we'll get 24x plus 4. Okay, so we're going to take each of our x values in turn. So let's start with x equal 0.560. We're going to need to find the y value. So we need to put that into the equation of the cubic graph. Now this is where, if I was doing this in an exam, I would find my first x answer and then do all of this to find the y and find the d2y by dx squared, because then you'll get the full answer on your calculator. So I've rounded up to 3 decimal places here, but you can keep the full thing in your calculator then if you do them one at a time. So y turns out here to be 1.970. And then d2y by dx squared is going to be 24 times 0.560 plus 4. So at this point it's 17.44. That's greater than 0. Therefore it's a minimum. Okay, so that's looking at our first x coordinate. Then we're going to go to look at the second x coordinate. So this time x equals minus 0.893. So y is going to be 4 times minus 8.93 cubed plus 2 times minus 0.893 squared minus 6 times minus 0.893 plus 4. And when we work all of that out, we get that y is 8.104. And then find the value of d2y by dx squared. So it was 24x, so 24 times minus 0.893 plus 4, so 24x plus 4. When we put that in, we get minus 17.432. That's less than naught. Therefore, it's a maximum. And then summarise our answers. Okay, so our first x coordinate was 0.560 and the y coordinate that we got with that was 1.970, and we found that it was a minimum turning point. And then the second one, we get minus 0.893 is our x coordinate, our y coordinate 8.104, and we found that this was a maximum. And again, it's what you'd expect, one of them to be minimum, one of them to be maximum. Okay, so our second one, and again the question's exactly the same. Find the turning points and state the nature. So this time our curve is y equals 3 plus 2x minus x squared minus 2x cubed. Same method, differentiate, and we get 2 minus 2x minus 6x squared. We know that for turning points, dy by dx equals 0. So 2 minus 2x minus 6x squared equals 0. Again, this one doesn't factorise. I'm going to write it in the format that we're used to, with the x squared, then the x, then the number. And I'm going to use again the quadratic formula. Minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. And this time our x coordinates are minus 0.768 and 0.434 to 3 decimal places. So again, I need to find the y values and I need to find d2y by dx squared for each of them. So d2y by dx squared, differentiate our dy by dx again, and we get minus 2 minus 12x. So our first x coordinate then, minus 0.768. So find the y coordinate by putting it into the equation of our cubic. So it's going to be 3 plus 2 times minus 0.768. And again, if you did this one at a time when you found the answer on your calculator, you could just use the answer button and you wouldn't have to keep typing in the whole thing again. Minus 0.768 squared minus 2 times minus 0.768 cubed. And when we put all that in, we find that our y value is 1.780. And then finding our d2y by dx squared, it was minus 2 minus 12x, so minus 2 minus 12 upon minus 0.768. That turns out to be 7.216. That's greater than naught. Therefore, it's a minimum. And our other x value then is 0.434. So find the y coordinate again by putting it into the equation of the curve. 3 plus 2 times 0.434 minus 0.434 squared minus 2 times 0.434 cubed, and this one here gives us a y value of 3.516, and d2y by dx squared then minus 2 minus 12 times 0.434, we get minus 7.208. That's less than naught, therefore it's a maximum. And again, that's what you'd expect, one to be a minimum and one to be a maximum. And again, summarise your answers, make it easy for an examiner to see exactly what our answers are. So our first point, this is our x value, this was the y value, and we found that it was a minimum. For our second point, this was our x value, this was our y value, and we found that it was a maximum. Okay, and our third one then, y equals x upon x plus 4 upon 2x minus 1, and again the question is find the turning points and state the nature. Okay, so the first thing we're going to have to do is multiply out this to give us our equation that we can differentiate it. Now we could get, because obviously multiplying out 3 brackets is part of your course, this could have also been a bracket, it could have been x plus 1 or something like that. So you'd have to multiply out the 3 brackets, but this should be a straightforward one. We just multiply out our 2 brackets here, tidy them up, and then multiply by x, and we get 2x cubed plus 7x squared minus 4x. So again, dy by dx, we get 6x squared plus 14x minus 4. For turning points, dy by dx equals 0. This again doesn't factorise, so again using the quadratic formula. So our minus b plus or minus square root of b squared minus 4 times a times c all over 2a. And our 2 values for x this time are 0.257 and minus 2.591. Again, we need to find the y values and our d2y by dx squared. So d2y by dx squared, it's going to be 12x plus 14. So again, take each x value in turn. So x is 0.257. So our y value, again, you can put it into the cubic with the brackets or the multiplied out version, whatever one you'd prefer. So let's put it into the one with brackets. 0.257 upon 0.257 plus 4 upon 2 times 0.257 minus 1. And when you work that out, the y value is minus 0.532. d2y by dx squared was 12x plus 14. So 12 times our x value plus 14. And when you work this out, it becomes 17.084. That's obviously greater than naught, therefore a minimum. our other point for x was minus 2.591. So again, putting it into our equation for our cubic. And then working that out, we get that y is 22.569. And putting it into our second differential, 12 times minus 2.591 plus 14. And we get minus 17.092. That's obviously less than naught. Therefore, it's a maximum. Okay, so summarising our answers. Our 2 points are 0.257 minus 0.532, and that was a minimum, and minus 2.591, 22.569, and that was a maximum.